Welcome back. In this one, we're going to be talking about wrapper classes, and we'll do a little bit of coding. We'll code stats, which is basically statistics from last year. That was a really hard problem, or a really hard project, but we'll see that ArrayList makes it significantly easier. At first glance, ArrayList seems strictly better. What's the catch? There's a few things that's actually kind of a catch here, right? We saw in the last video that the dynamic sizing of ArrayList can be a problem if you're not prepared for it, right? Elements shifting as you're looping, that could be a problem. But a big one is that ArrayList can only store objects, not primitive data types. This has to do with those angle brackets and the generics that I keep name dropping but never explaining, and I'm not going to explain. But we can only store objects in ArrayList, okay? So that means if we tried to create an ArrayList of int or an ArrayList of double or ArrayList of char, any of these primitive data types, it's going to be a compile time error. You just can't do this. However, there is a simple workaround. Let's just take the primitive data type and wrap it up in an object. It's kind of a dummy object. It's a wrapper, as the name suggests. You have the integer, and you're going to kind of put a object around it. In Java, there are object versions of all 8 primitive data types. These are known as wrapper classes, right? So for Boolean, we have Boolean with a capital B. This convention where our object begins with a capital letter, right? This is because we name our class with a capital letter, and we get basically data types from there. I want you to note that char, the wrapper class for it, is character spelled out, and also int is actually integer spelled out. But for every other primitive data type, it's just a capital letter, and you get the object version. So these are pre-made. These already exist. They work by encapsulating the respective primitive data type as an instance variable. Right here, we see public class integer. So we're talking about the integer wrapper class. Here's a constructor for it. It's going to take in an int, a primitive data type, save it into the instance variable, and there you go. You have an integer, but it's inside of integer, the object. In the case of double, same philosophy. We have the double class. You see a double constructor. It's going to take in the double primitive data type and just simply save it in an instance variable. So you have that double wrapped up in an object, and right, that's effectively, it's the same thing. Now we can create an array list using those wrapper classes, right? We can create an array list of integer. This is the integer wrapper class, but there is effectively an int instance variable inside of all of these. There's a double instance variable in each of these. There's a Boolean instance variable in each of these. These wrapper classes are part of the default Java library, that is java.lang, so we won't need to import those. We already have access to them. Here's the trade-off. We're now working with objects, not primitive data types. Okay, which means that if you want to make an integer, you need to go through a constructor, right? It's an object. I have to call the integer constructor, passing in the int that I actually want to wrap up. And then it's inside of that object. So if I want to do math with it, I got to pull it back out. This is effectively a getter or the accessor method inside of the integer class. But it's basically just we're going to take our integer object and pull the int out of it. Then I'm working with an int primitive data type so I can do some math. Lucky for us, smart people write programming languages, so this conversion between primitive data type and the respective wrapper class is actually going to be automatic. What do I mean? Let's take a look. I have an array list of doubles, double objects, right? And I want to add 3.14. This is not a double object, right? Look at this. This is a double. This is a double primitive data type, but I'm adding it to an array that accepts the double object. In theory, it don't work like that. Those are two different data types. Simply put, Java sees you're trying to add a double value to an array list that stores double objects. Behind the scenes, under the hood, whatever phrase you want to use, a call to the double constructor will be made before adding the element to the array list. So whenever we're doing this, what's going on behind the scenes is this. We're calling the double constructor. We're creating a new double object, and we're using the value that we wanted to add as a parameter to this call to the constructor. Right? That's going to create a double object, and then that's what is being added. Right? This is going to create a new double object right here, and I'm saying let's add that to nums. The process in which a primitive data type is converted into an instance of its respective wrapper class is known as boxing or auto-boxing. Now, I have a bit of a rant here. These classes, they're called wrapper classes. Why isn't this called wrapping or auto-wrapping? Or vice versa. These could be called boxer classes, if you're going to call this boxing and auto-boxing. Whatever. Conversely, Java will automatically unbox wrapper objects into the corresponding primitive data type. Take a look at this. I have 3.14, and I'm saving it into the double object pi. In theory, this shouldn't work. This is a primitive data type. This is an object. It does work because behind the scenes, it's going to make a call creating a new double object using 3.14. Okay, so that is wrapping up the object, that is boxing it, but we can unbox it. Right here I'm taking pi and I'm saving it into a double primitive data type. That shouldn't work. The data type of pi is a double object. I'm trying to save an object into a primitive data type. What's really going on behind the scenes under the hood is a call to pi.doubleValue. This is just an accessor method. It's pulling the double value out of the object before saving it into the variable. For you, the user of these wrapper classes, auto-boxing and auto-unboxing leads to a seamless experience, even when doing arithmetic operations, right? Take a look at this example. I have an int that I'm trying to save into an object variable. That shouldn't work. Down here, I'm doing some math. I'm taking that object and trying to add it to 300. That shouldn't work. There's a lot of stuff going on behind the scenes here. Let's step through it. So in this above example, num is going to be auto-boxed into an integer object. We'll take this 1337, we'll wrap it up into an integer object, then save it. So we're boxing it up. The arithmetic operation occurs on the next line. We have num, which again is an integer object. We need to auto-unbox it so that we can do math. Right? We're going to call the accessor method to pull the int out of the object, then perform the math. That is going to produce an integer, right? When I auto-unbox this, I have an int, primitive data type, plus an int, primitive data type. The result is an int. I'm then trying to save that int into an object. Well, that is going to be boxed back up before we save it into X. All of that happens seamlessly. Like this just works, and all this other stuff is happening under the hood, right? This is a seamless experience for you. In fact, I have students even in CSP accidentally use the like the double data type with a capital D, right? I got students that are using these things accidentally. They didn't mean to. They just put in a capital D, and their program works. They never even noticed a difference. So that's kind of what I mean here for you, the user, this being just a seamless experience. Let's code stats. Okay, write a class stats that implements the following public interface. First thing I want you to notice is this stuff is not underlined. We're not going to make a utility class. We're going to look at a slightly different approach where we actually have an array list as an instance variable. But we'll have our constructor. We need a way to actually get values, get doubles into that array list. We have total, average, in the very much so dreaded mode. Let's get started. I'm in IntelliJ, and I'm going to make a new project by going to File, New Project. I'll go Next, Next. I'm already in CSA, so I will make a stats class. Project folder, I should say. I'll expand my project folder, right-click on the SRC, make a new Java class called stats. Okay. So taking a look at this public interface again, what's different is These things aren't static, right? The array list they're going to be working with is an instance variable. So let's create that. I'm going to go private array list double. Let's call that list. Notice that array list needs to be imported. Double does not, right? The red here is because we need to import array list. Again, we can hover over that, hit Alt Enter, and it'll import it for us. But double, I don't have to do that for. This is included in the Java default library. So I have this array list instance variable. Let's create our constructor. You'll notice our constructor, no parameters. We're going to go public stats. Purpose of our constructor is to initialize the instance variables. There's only one in this case. I've declared a variable. This variable will exist over the life of the object. But as it stands right now, it doesn't have a value. It's pointing at null. I want to tell it to point to a new array list of double. No need for a length. We're working with array list, right? This is going to be dynamic. Initially, there's nothing in it, and we're good to go. It's important to note that the array list is inside of the object. So if I want to get values into the array list, I got to go through the object to even see the array list, meaning we're going to need this method, add value. Note that it takes a double primitive data type. Right, I'm going to go public void add value, and we're going to take in a double. That's the value that I want to add. Okay, even though this is a double primitive data type, in my array list takes a double object, I can simply take my list and add the value. Right? It is a double primitive data type. Right here, it's going to get boxed up. What we're actually doing is saying new double using that value. That's going to create a double object, which then gets added to the array list. Again, I have to have this method because I don't have like direct access to the array list. It's actually inside of the object. So I need to go through stats in order to see that. Why don't we actually take a look at what we got so far. I'm going to create a toString method. And again, the actual array list is inside the object. So if I want to see it, I got to go through the object, through the object's toString. And so why don't we return, just simply put, list.toString. Right? If I tried to return just simply list, that's a bit of a problem, right? We know from working with array lists that or just objects in general, if I tried to print them, there's an implicit call to the toString. If I tried to add them to a string, there's an implicit call to the toString. If I just try to return it here, however, the data type of list is array list of double. What my method returns is a string. So I can explicitly call the toString method to basically get the contents of the array, right? That's going to show me the contents of the array in something like this. Right? List is an array list, and it has a toString method. What it does is it shows me the contents. Okay. Slight cheeky way of doing this. This is really what I recommend is doing this. But as I just said, anytime you concatenate an object with a string, you're going to call the toString. So we could add this to effectively nothing, and we would call the toString. Let's actually try this out. I'm going to right click on my SRC, make a new Java class. Let's call that driver. I'll plug in a main method with PSVM, and we are going to make a stats object. Okay. The array list is inside of this, which means in order to get values into that array list, I'm going to go through the method that we made called add value, right? Something like 3.14. In order to see this, I would need to print off my stats. Let's right click in free space, tell it to run. There's only one value there. And we can see that content's there, right? Here, when I say my stats, what I'm doing is calling my stats.toString. That's going to go into the stats object, call this toString. What does it do? It is going to basically do list.toString. Right, that's going to show me the contents of the array list, which right now is only 3.14, and that gets returned, and then that gets ultimately printed, and that's what we see here. Right, we can add more values by going to my stats, add values, or add value. And there we go. Okay, let's get some stats going here, right? Total is one of our methods. I'm in my stats. We're going to do public double total. That's it. It's not static. It doesn't take in any parameters, because what we're finding the total of is this array list that is an instance variable. It's inside of the stats object. We've done this several times, so I'm going to create some type of variable. I'm going to call it sum or total. I like to use a different name so I don't really confuse students. But we're going to create sum, which starts out as 0. And I'm going to loop through my list. Okay, I don't need an index here, so I'm actually going to use a for each loop. Right? The data type of each element in list is a double object. So I'll say for each double, which I'm going to call, I don't know, X in my list. With each iteration, I want to take that thing, add it to my sum, so that we kind of get a running total. Sum is going to be plus equal X. After the loop is over, I'm going to return my sum. Okay, let's try this out super fast, and we'll talk about a couple of things. Right, in order for me to see this, I need to print it off. I'm going to take my stats object and find, no, not the toString, the total. Again, that array list is inside of the stats object, and we see that here's our total. That's looking pretty good, but one of the things I kind of want you to realize is here I'm using a double primitive data type. Here I'm using a double object. It doesn't matter. I could even like flip these and it should be okay. I may be wrong on this for each loop. Oh, it doesn't like that. What if I did 0.0? It likes that. Right? For me, it's kind of a seamless experience. It didn't like this because this is an integer until I put the 0.0 on there. But for me, the user, I could even do double like this. This is a double primitive data type, yet my array list is filled with a double object. There's boxing and unboxing that is going on, and it's okay, right? For me, it doesn't really matter. So this is a very cheeky thing to do. My array list can't hold primitive data types. It can only hold objects. So there's these little wrapper classes, they're kind of like dummy objects, right? Where we just take whatever value that I need to be an object, and I throw it into an object, and there you go. Everyone's happy. Okay. Our next method is going to be average. We got public double average. Okay, don't think too hard. We already have a total method, right? The way that we figure out the average is that we basically figure out what is the total value of all the numbers, then divide it by the total number of numbers. Well, I've already done part of that. So instead of rewriting that, I'm just going to use what I got. I'm going to return total divided by the number of elements that are in my list. The number of elements that are in my list is, of course, list.size. Easy. Let's see what we got. That's looking pretty good. We can maybe play with both of these things by adding some type of number. And there we go. All right, last one, mode. And I promise you it's going to be easier than it was last year. It still ain't easy, but easier. Mode, take a look at our return type, is returning an array list of double. A mode, simply put, is the numbers that appear most frequently. In theory, it is the number that appears most frequently. The problem is numbers can tie, right? So that's why we have an array list of double. In the event that we have only one, we get back an array list with only one element. But if we have multiples, we have the data type that can deal with that. So we're going to go public. The return type here is array list of double. First time we're seeing that. The name of this method is called mode, and I don't need any input. What I'm finding the mode of is already in this object. It's list. Okay, let's get an example list going maybe. How about something like this? Okay. My strategy is going to be the same it was last year. I'm going to figure out a count, right? I'm going to basically loop through this array list. I'm going to have 7. I'm going to count how many times does 7 occur. 1, 2. Okay. I'm going to store a 2 there, right? So if I want to know how many times does this element occur, I go get the corresponding index. I see 2. I go, okay. I move on to the next element. I want to know how many times does 3 occur. I've got 2 for that. How many times does 23 occur? I've got 1 for that. And we'll put a space there so that lines up. 42, 7, 9, and 3. So we'll go through and we'll count the elements. Maybe the space is not great. We'll count the elements, right? So if I want to know how many times does 9 occur, I get the corresponding index out of this array, which we're going to call counts, right? And this is my list. If I want to know how many times 23 occurs, I get the corresponding index out of counts, and I go, okay, that's 1. How many times does 3 occur? I get the corresponding index, it's 2. So this is my first goal. Let's get these counts. I need to do that. I need to count every element before I can determine which one occurs most frequently. All right, so let's create an array list of, hopefully you guessed it, integers, right? These can technically be doubles, right? 7.0, 3.0, but I mean, it could easily be like 3.14. But my array list that stores these counts, I can't have a number appear a fraction of a time. So this is definitely going to be an integer. Counts as a new array list of integers. I'm ready to start counting. I'm going to loop through my list. I want to, for each element, I want to count how many times it appears. One thing I'm going to recommend here is a private helper method, right? One that counts. We could do it without it. You're just looking at nested loops, and I tend to try to clean this up while also throwing in some method practice by just writing these little helper methods, right? I'm going to create private int count. We got to have a double that we want to count, right? And we'll actually Javadoc our private method, just because I need to, clarify what this is actually doing. Count is going to return the number of times x appears in list. Right? X is this variable here. It's listed as a parameter. List is this thing up here. Okay? So this private helper method is very tailored to just counting in list. Okay, just don't worry about mode right now. Just think about count. All we got to do is create some type of integer. And then we're going to loop through our list. I don't need an index. I will say for each double, which we'll refer to as num in our list. If the current element is equal to the one that I'm looking for, then we're going to increase count by 1. After the loop is over, I can return my count. Okay, something of note here, again, this is a primitive data type, this is an object. So when I get here, this is a little bit awkward. I'm taking an object and trying to compare it to a primitive data type, and there's just going to be unboxing that happens. This will get unboxed before this is compared, and so this is safe to do. It's a seamless conversion. Conversely, even if that doesn't work, we could just make this a double, so it definitely gets unboxed. Right? It would get unboxed whenever whenever the number gets saved into this variable here. Because keep in mind, what's actually happening under the hood here is that we are creating a double with each iteration called num and setting it equal to effectively listed I. Right? This is a double object. It will get unboxed, meaning even under that hood, we're taking listed I and calling the double value method the accessor that's pulling the double, the primitive data type, out of the object before we save it in here. Okay, so this method should give me a count. It should count the number of times that X appears in our list. Notice there's a loop here. We could do this up here, but I'm trying to make this a little bit cleaner. All right, I want to loop through my list and count how many times each element occurs, and then just add that to my counts. Okay, let's loop through list for each double, which I will refer to as X in list. I want to count every one of them. I want to count how many times the current element occurs. Right? If I call count at X, count of X, right? I want to know how many times does 7 occur in list. This is going to tell me that. Right? So what I have highlighted right now based on my example, that's a 2. It's just sitting there. What I want to do is get it into my counts. Right now counts doesn't have anything in it. So I want to take counts and I want to add this value. We could break this apart over multiple lines, but I am looping through. I want to count how many times the current element appears in my list. Right, that's going to call this count method down here. We'll get a value back, and that's what we're adding to counts. Right, in my example, that would be a 2 that just got added. On the next iteration, it would be a 2. On the next iteration, a 1. So once this loop is over, this is the value of my counts. Okay, now what? Now I want to know what is the largest number, the maximum number that appears in my counts. We've written a max method plenty of times. You can make a helper method here if you want, but it's just a single pass over. I'm going to create an integer called max. And initially, I'm going to set it to the first value. I'm going to say that max is counts.get 0. Again, this is an integer object. It will be unboxed before we save it into this int primitive data type. That is, I'm calling counts.get 0 .int value. You don't even have to worry about it. For you, the user, it is a seamless experience. All right, so I got the first value. I'm going to loop through the remaining bit of counts. I'll use a for loop here because it's more efficient for reasons we've talked about. I'm going to start at index 1. because I've already considered index 0. And we'll say as long as I is less than counts.size. With each iteration, I want to know, is the current element actually less than my previous max? If the current element, that is counts.getI, that's a number, I want to know, is it actually smaller than my previous max? I'm sorry, greater than my previous max. If it is, I have a new max, so I'm going to update it. Max is going to be the current element. Okay, in our last video, I showed how you can use a for each loop to do this. The for loop is technically more efficient because we get to skip an iteration. It's not by much, but here we go. Once this finishes, I should have the maximum value stored in max. That is, max is going to be, in my example, a 2. Right? I would loop through and figure out that 2 is the maximum value that is in counts. I now, one last time, want to loop through my counts. I'm going to, with each iteration, ask, is this equal to my max? In this example, it is. I'm going to get the corresponding element out of my list. And I want to add that to a different array list, the one that I ultimately plan on returning. Let's create that array list. Ultimately, what's going to be tucked into it are the actual numbers, right? These things from the original list, which is ultimately a double. So I'm going to create an array list of double. I'm going to call that modes. It's going to be a new array list of double. Okay. Now, I want to loop through counts. With each iteration, I want to ask, is this equal to my max? If it is, I want to add this to modes, the element at the corresponding index. There is one caveat to that. I don't want duplicates, right? If let's say this is a 2, I go get the 7, I add it. I get this, I go get the corresponding element, I add it. But I get down here and I try to add this 7. Well, I already have a 7 in there. Very fortunately for us, there's already a contains method for modes. Okay, let's loop through our counts. I do need the index here, right? Because I have to get the corresponding element. So I'm going to use a for loop. Ultimately, we're looping through counts. It shouldn't matter which array list you choose here. They have the same length, but I want to make it very clear that I'm looping through counts. I'm going to ask with each iteration, is the current element equal to my max? Does the current element equal my max? If this is true, I want to add it to modes, but I only want to do that if modes does not already contain that element. If modes contains the current element, the corresponding element, I should say, this bad boy, that is list.getI, what I want to know, does it not contain it? If modes does not contain the corresponding element from my list, then we are going to add it. It, in this case, is the corresponding element. Right. Let's take a look at the logic. We're going to loop through counts. I'm going to ask, does the current element equal my max? Okay. It does in this case. All right, we'll enter that body. There's another if statement. If modes does not contain a 7, then modes.add 7. At this point, my modes, based on my example, will have a 7. Okay, I++, we're now here. We're going to ask, is that number equal to my max? It is. Is the corresponding element, 3.14, not in my modes? It's not. Okay, let's add it. That's the end of the iteration. We'll do an I++. We're now here. We're going to ask, is that number equal to my max? It is not. We do an I++. We're now here. We'll ask, does that number equal my max? It does not. I++. We're now here. We'll ask, does that number equal my max? Yes. Does modes not contain the corresponding element? The corresponding element is a 7. That's already in my modes, so we'll skip this, do an I++, and that'll prevent the duplicate. We're now here. We'll ask, is that equal to my max? It is not. We'll do an I++. We're now here. We'll ask, does that equal my max? It does. Is the corresponding element not in modes? Corresponding element is 3.14. That is in modes. So we'll skip this. This is the final values in my modes, and we'll return that. Let's try it out. I'm going to flip over to my driver. I want to do a system.out.println on mystats.mode. In this particular example, all my numbers are the same. Well, I only have one of each, I should say. So they are all effectively modes. They all appear the most frequently. Let's just simply add in another value, a matching value. Now 7 appears most frequently. There's only one mode, and you see that my array list consists of only one value. What if we have 2 modes that are tying, yet there's multiple values? We'll do another 23. In this case, I should get 7 and 23. Okay, I'm going to flip back to stats, give you one good glimpse of mode, and I'll see you in the next one.